Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet and the topic was tree. And the very first pattern, which is BFS Traversal, we have already discussed how to traverse depth wise using the recursion, and also we have solved 3 different questions. Now in this video we'll see the second approach of traversal, that is breadth first search, and we'll try to understand this traversal using the very first problem, which is binary tree level order traversal. So to understand what is breadth first search, let's try to understand what the question asks, and this is very basic question in binary tree level order traversal. So as you can see, the root of the binary tree has been given. We have to return the level order traversal. But what is level order? If you see the example number 1 and the output, in the very first list we have to print 3. In the second one we have to print 9 and 20, and in third we have to print 15 and 7. So can I say we have to print all the nodes? Level means level 0, level 1, level 2 and so on. Means if we talk about this tree, level means this will come at level 0, okay, this will come at level 1, this will be at level 2 and this will be at level 3, okay. So we have to print the list of list, we can say, where we have to print every numbers which occurred in that level. So 2 and 3 are the nodes which occur at level 1. Okay, this is a task which we have to do. And if you remember, in the depth first search, when we started from this route, we had 2 choice, left or right. We decided to go left first, correct, or else we can decide to go right also. It depends on us or the question what it is asking. But in level order traversal, when you have 2 options now, you have to take both one by one. But in DFS, when we choose one and we had 2 options and then we decide to go with 2, it's not like ki after 2 go on 3, no. When we decided to choose 2, again from 2 also we had 2 options, 4 or 5. Now again from 4 also we had 1 or 2 options, 8 or something. Now when we return back, then on 2 again we have other option to choose, which was 5. But in level order traversal, once you choose the parent, you have to choose all the children together. It's not like you go on 2 children, return back and then come to 3, no, okay. So let's read the constraint. It says the number of nodes in the trees can range from 0. Why we read this? Because if it is 0, means we have to write the base case. Ki what if root is null, then return null. And the number of maximum nodes is 2000. Okay, maximum number of nodes are 2000. Okay, that we'll see later ki how the time complexity will affect or it gives TLE or not. Okay, node values can also be from minus 1000 to 1000. Why we read this also? Because if we have to do some summation and we know in integer, like this can hold up to value 10 power 9, right? So if it is more than that or like that, so if we have to add multiple numbers of 10 power 9 size, then integer cannot hold it and we have to convert this in long format and all. But the question already says ki it's 10 power 3 to 10 power 3 minus 2 positive, okay. And anyhow we do not need to add the values, so we don't need to worry about it, okay. Always make a habit of reading the constraints because it is very important if you really want to build the logic on your own. Okay, so now come to the part ki we have to print this. Earlier we are starting at 1. Suppose we don't know how to traverse BFS, breadth first wise. Now though, as of now, you are following my playlist, so for sure you know how to traverse depth wise. Okay, so using the BFS traversal, when we were at this node, we had 2 choice, left or right, okay. We decided to go at 2, then again 4, then again 8, then come back, and then 5, then again come back, then 3 and so on. What do you think? Like using the BFS traversal, can we print level wise? Think again. I am at root here, okay. Now I am going towards left or right, okay. As it is recursive, so like first any one call will make, okay. Now don't you think, like even if after 2, 4, 8 and then 5 and then come back and then we go to 3, there is any common thing which is same for 2 and 3? Think about again from parent level, if we want to give something so that ki we can identify ki they are at same level, what will be that thing? Can I say if I am starting from here, okay, give it a extra variable, let's say level, okay, So in the DFS function, okay, we will give root, yes, and we will give level. That's it. Yes. And now the base case, if root is null, return, can I say? Or else we will call for left, we will call for right. That's what we did, remember? DFS call, we sent root dot left. Yes, DFS call, we sent root dot right. This is so common. What next? What do you think? If this is at level 0, left and right call should be called for what? Can I say level 1? Level 1 is nothing, means parent level plus 1, because here to it will be level 1. Next time it will be level 2 now. So we'll just check what was the level of its parent and then add 1 extra. Can I say that? Yes. So we will do level plus 1, level plus 1. Very simple. Now what will happen? Coming like from here, I had one level 0, right? Okay. Now here level 1, level 1. Now we had to make 2 calls, but recursively we will be able to make only first call, whatever we have written. So we have written for left side, so left call will be done. Once we did the left call, again for 2 it will check is root null, no, then again for 2 we will call for left and right. For 2, left and right, but as left is first, so we will call this. So what will be the level? Can I say 2? Similarly for 4 also left and right. So first left call. So can I say level will be 3? Now for 8 also left and right, but as left and right are null, so it will check and it will return. So for 8 both left and right are nothing. Can I say that? Okay. Then we will go back. Again on right it's null, we will go back. Listen it very carefully. Now for 2 you made left call, but you did not made right call, remember? But now to you are returning. So when you will make call for 5, the level of the parent will be 1. And who remembered it? The stack calls. Stack call has remembered the level of every parent. Okay. Now level 1 plus 1. Again for 5 the level will be 2. That's it. Now again you will be return to it, and now for 1 we called left, remember? Now we have returned, so we will go for right side, but stack call has remembered the level 0 for its parent 1, so now it will be again level plus 1, which is 1, so this will be 1. Next time for its parent 2, similarly 3. Now we will return back, and now for this we will go for next level, which is 2. Correct? Now what we did here, I can say one thing now, key level though I can print, correct? Even using DFS function also. But how will I keep track? Like, because we made levels, for sure we want something. What we want? Key, if we had something like data structure like this, okay, means list of whatever you say, list of list, then in 0th index, like we can say all these indexes are nothing but levels. So in this level, print the root value. In this level, print the root values, means node values. In this level also 4, 5, 6, 7. Here also 8, 9. This is what I want. How to print this? Can I say after the null check, before calling for left or right, you can do either ways. Means here I am and I have checked ki I am not null. Okay. So if I am not null, before going for left and right call, why not to do one thing? Save me. Save my value, because I have level also and I have my value also, correct? So what I will do, whatever this is, let's say answer. So in answers index, okay, answers ith index, means can I say level 0? Level is nothing but index. So answer, can I write like this, ki answer dot get level, not I, sorry, level. So answer dot get level, what it will give, ki in the answer, go at 11th index. Done. Now here I have to add what? Can I say node value? Yes. So I will say dot add what? Node or root. We have root, right? So root dot value or data, whatever it is. So this piece of code, okay, we have to add here. That's it. What we did? This piece of code we have to add here. And at the end we can simply return our what? This answer. This is what expected, right? So this is how, using the DFS function, we have got our answer. Okay. Now the main concern is कि initially we don't know how many levels will be there. So how can we decide कि how many list we have to initialize inside the answer? How do we know that? See, without traversing, we can't know, because we don't know how many levels are there. So for sure, while traversing, means once we encountered a new level, I can say कि I have to insert what? A new list inside this answer list. Can I say? Yes, I can say कि I have to insert a new sublist inside this answer list. But when? See, initially, suppose we have nothing in our answer. So can I say the level, like the size is 0, and initially what is the level? 0. So can I say if my level is 0 and my size is 0, means level is 0, means can I say I want one list? So I can put inside it what? I can insert a new list inside this. That's it. Now next time when we'll go here with the new levels, level 1. So again I can say ki is my level equal to answer size? Why answer size? Because currently the size is 1. Level is also 1. But as it is 0 based indexing, because we started with 0, right? Level 0. So as it is 0, so what we have to say? We have to say ki if my level is also 1, okay, and size is already 1, means one more extra list we have to insert, correct? So after this root null check, here we will add that extra line. What's that line? Ki if level equal to answer dot size, okay, we have to add in answer what? New array list. That's it. And after this line we will write all these 3 lines of code. And that's it. I hope this is clear. So can we write the code for this? See, here is the code which we have discussed. First we will make the array list, and now what we will do, ki initialize the root and send this answer, and level will be 0. Okay. Now we'll make this DFS call. Inside this we have to check if our root is null, first the base case, then this is a condition to create a new sublist inside the list, okay. And now once done, in our answer, because after insertion of the new list only we can go na ki hey, now get that list by the level and put the values. If you will create this after line 19, then it will give you error ki hey, this new index is not found or is out of index. So hence we need to create that extra sublist inside the list, and then in that only we can put that root value. I hope you know the reason why we have inserted this line of code at first. Now once done, go for the left call and right call with level plus 1, and that's it. So the time complexity here will be O of n. Why? Because here you have traversed at every nodes just one time. And space complexity will also be O of n, because this is recursion. So every function call will get saved in the recursive stack. And this thing we have already discussed in our DFS traversal video. Remember? So now the space and time complexity both in this case will be O of n. So as the number of nodes are just 2000, so definitely the code will be faster. But the thing is, question did not expect that. Although we have printed the exact thing, which is level order, but this was not exact level order traversal. We tried to print or bring the answer using the DFS traversal, but in reality the BFS traversal does not use recursion. Means it does not goes depth wise, but it traverses level wise. And how we can do that way? Let's see. In this particular traversal, we use extra data structure, which is queue data structure. Why we do so? See, level order traversal says once you encountered any node, finish all of its children at that level. Okay. So the idea is very simple. Once we encountered a root, in the queue data structure, we will insert that node. Then, now what we will do? We have to print this and put it in the first one. And now we have to insert its children. So we'll pop this node. We will pop and in store in node. So queue dot poll or pop, done. So we'll insert this in node. Now we have to insert its all children, means left or right, whatever are present. So in this case, left is present, so we'll insert 2, right is also present, so we'll insert 3. So here we'll check if root dot left is there, not null, then in queue offer what? Root dot left. Very simple. Similarly, if we have root dot right, then queue dot offer root dot right. Very simple. Okay, what I am doing, I am writing every line of code whichever I am understanding. So as of now, I can say ki, like if you are thinking about the base case, so initially only you can check ki if root is null, return null. Okay. Apart from it, once if any node is there, insert that in queue and start iterating. Means pop from the queue, check if they have left root or like left child or right child. If they are, then put in the queue. If it is not, means in the queue it will not be there. Means can I say we have to stop when queue will become empty? Yes. So can I put this line of code, this whole line of code in a while loop ki while my queue dot is empty. Ki until my queue is empty, keep doing this. Done. Now whatever we have popped, can I say ki we have to insert in our answer array list? And also for every level we have to insert sublists inside this. Means we have to create a new sublist at every level. Now how to keep a track of level? If you will write this, only this line of code. So one will get popped, done. You will say ki in like answer add node value which is 1. Okay, answer will say okay, added. Now next time you will put left child and right child in the queue, again done. While queue empty, no, it is not empty. So 2 will get popped. Again you will add 2. Now 2's left and right child you will insert, which is 4 and 5. But wait, don't you think 2 was not expected to add in the same level as 1? Correct. Means 1 was supposed to be add in some another sublist and 2 and 3 were supposed to be asked in some another sublist. So what is that extra line of code or extra logic which will make this possible? Okay, listen it. Before inserting 2 and 3, what was the size of queue? 1. And we wanted this only 1 to go inside this extra sublist, right? Now once we popped 1 and put all their children's, what was the size of queue? 2. And that's many number of nodes we wanted in the next level. So can I say inside this, like inside the while loop also, we have to run a for loop by queue size, and that many numbers of nodes we have to put in the new sublist. Does that make sense? What I said create the list of type integer. Okay, let's say array, new array list. Done. This will be our sublists. Done. Now we have to take the size also. So size will be nothing but queue dot size. Done. Now what I said, that many number of times run the for loop. For int I is equal to 0, I less than size I plus plus, and that's it. And here in our array add that node value. That's it. Now what I did, see very carefully. Until our queue is empty, yes, initially let's dry run this one by one. At initial we had 1, right? So we have created a new sublist. Now inside this all the node will go from queue in the sublist. Okay, we have calculated the size also. Size is 1. For loop will run for only one time. Now we'll pop the node from the queue. So 1 will get popped. Yes, and currently node is 1. Now in the sublist, which is this, we'll insert node.value. Now in the queue we'll check if we have root dot left and right. So yes, we have. So 2 get inserted, 3 get inserted. That's it. Now for loop will break, will come out of this for loop. Now this is the sublist we have. Now what's the expected task? Can I say this sublist is supposed to go inside our answer list? So after coming outside this for loop, yes, we have to write answer dot add array. Array is nothing but level. So you can either say array or you can either say level, whatever the name of sublist you want to give. And now we can say ki yes, this sublist now inserted inside the answer list. That's it. Now what will happen? Again we'll go here. Q is not empty. Yes, they are not empty. Size of like first we'll create a new array list. So now new array list will get created. Done. Now what will happen? Again we'll calculate the size. Size is 2. Now for loop is supposed, this time the for loop will run for 2 times. First node will get popped. So node value is 2. Can I say? Yes. And in the array, which is a new one, we will insert node.value, which is 2. Very simple. Now we'll check ki does 2 has left child? Yes, it has. 4. Now 2 has right child? Yes, it has. So 4 and 5 we will insert. So see, 4 and 5 will stay in the same queue after we have popped 2. But along with 3, it will not get printed. Why? Because of the for loop. For loop will take care ki till what the number of nodes were supposed to be inserted at that level. Okay. So now we have inserted 4, 5. Now what will happen? Again this for loop will run because this for loop was supposed to run for 2 times. So next time 3 will get popped out. Yes. Again we'll check for the children of 3, 6 and 7. Yes, 6 and 7 in the queue it will go. And here in the array 3 will get inserted. Array is nothing but that integer inner list, sublist. Now for loop will break and in the answer we will insert array. So in the answer we will insert array. Okay, so comma and we will insert this one here. That's it. Done. Now again further it will go while my queue is not empty. Yes, it is not empty. Now again we'll create the new list. Again we'll create the new list. Done. Now we'll pop for first we'll calculate size. Size is 4 now. Now this for loop will run for 4 times. So first 4 will get popped out. 4 will get inserted in the array also. Yes. Does 4 has children? Yes. So in the queue 8 will get inserted. Now again 5 will get popped out. Correct? Yes. 5 will get inserted in the list which is array. Now does 5 have children? No, it does not have. So for 5 we will not insert any children in our queue. Next time 6 will get popped out. So 4 popped, 5 popped and 6 popped. Now again for 6 we'll add here in the list. Now for 6 do we have children? Yes. So 9 will get inserted. Now next time 7 will get popped out. 7 will get popped out. 7 will get inserted in the list. Okay. Node value 7. Now for loop will break and in the answer we will insert this much level here. Okay. So we will insert here. That's it. Next time again we will create a new list. Let's create a new list. This and node value will pop 8. So this time the size was 2. So for loop will run for 2 times. First we'll pop 8. 8 will get inserted in the list and 8 will get popped out from here. Now next time 9. So 9 will get inserted in the list and 9 will get popped out from here. Okay. Now what will happen? Will come out of this for loop. In our answer here in this list we will insert this 8, 9 also. So now our array will become what was expected. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now again it will go while my queue is not empty. Now this time it is empty. So we'll come out of this while loop. And now what we are supposed to return? This answer list. So this is what breadth first search calls. Means whenever we will pop out any parent node from the queue, our task is to insert their children in the queue. And next time instead of going depth wise, we will pop all the children's level wise. So here also if you talk about the time and space complexity, for space we have inserted every node, every 2000 or 5000 whatever number of nodes given in the constraint inserted in the queue. So definitely the size will be O of n. In the DFS function, space complexity was taken by that inner stack, but here it will be taken by the queue. Again the time complexity also if you will talk, you are running this for loop, while loop, you might feel that these are nested, so O of n square. No, we have run this while loop only to check is my queue empty or not for one time, and this for loop run for n time. Okay, so in total if you will check, we have run this for loop for all number of nodes but only for one time. Like we have not repeatedly came back at the same node and again started back. Okay, so hence the total time complexity will also be O of n. And also if you want the complete proof, what are the number of nodes we have inserted here? It was O of n, and that many number of for loop also we did, means to pop all the nodes. So in total O of n only. So BFS also takes O of n time complexity. DFS also takes O of n time complexity. Space wise also they are same. So which one is better? See, it depends on what the question is asking. Although it was about the traversal, which was breadth first search. So always go with Q data structure like BFS traversal until or unless question asks you or talks about the depth or the number of nodes. It's like when we are dependent on our children to give our answer, we mostly prefer DFS traversal. And whenever it is about the distance, number of nodes, level wise calculation, we go for breadth first search. Now the key point, if the interviewer says can we do this question using the DFS traversal, and the answer you all are aware, because in the starting only we have solved this question using DFS traversal. So say yes, it is possible, but as a question explicitly mentions it wants BFS traversal, so that is why we will apply the Q logic. Now let's write the code for this. So this is a code which we have discussed. First we'll create the array list, and first the base case check, because it is not DFS. So again and again we are not coming back to check. So base case will be checked for only one time. As the constraint says the number of nodes will be 0. If it was given at least 1, then the base case is not needed. Now we'll make a queue, and in the queue first we'll insert that root. Otherwise, if we'll check while queue is not empty, and if you will not put any root inside the queue, it will say yes, queue is empty, so go and don't do anything. So that is why it is very important to insert the first root in the queue. Now the same line of code, we'll calculate the size, we'll make the level or array whatever you want. Now run the for loop for that many size, and one by one pop from the queue, add in that inner sublist, check if they have left and right children. If they have, then put it inside the queue. After coming outside the for loop, you can say you have got all the nodes present at that level. So now the task is to add that level in your outer list. That's what we did. And at the end of this while loop, means once our queue become empty, we can say we are ready with our answer list. So hence we can return that. That's it. So let's run the code and let's submit this. So this was your Java code, and if you understood this, here is your C++ code with the similar logic, and here is your Python code with the similar logic, which is BFS traversal. So if you understood this, we can go in the sheet and mark the very first question of this traversal as done. Now going forward, we will do the questions as we already know what is DFS traversal and what is BFS traversal. So we will try to understand in what question what traversal suits better. And if you really like the pattern wise learning, then do like the video and let me know your suggestions in the comment section. And don't forget to subscribe if you have not subscribed yet. And that's it. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.